Hello, everybody. Today we'll see a method of analyzing a microwave network. A microwave network is nothing but any general input network which has incident voltages, reflected voltages, incident currents, and reflected currents. This network can be internally connected um, in any fashion. The input at any point can have an output at any output point depending on how the network is designed. So we will be seeing the way to analyze a network like this. Till now, typically, we have analyzed networks using KCL, KVL, and from that, uh, the standard way of analyzing them or creating standard way of analyzing the networks was using KCL and KVL, which led to creating of Z parameters, Y parameters, H parameters, and transmission parameters. So example of Z parameters is where in a single two-port network, the voltages and the currents from both input port and output port are related through a linear matrix. Y parameters where it is the other way around. So this technique, when while calculating the Z parameters, the voltage and currents are measured, and that is how the values of the Z parameters are found out. This technique cannot be extended easily to microwave or higher frequency networks because voltage and current measurements are not very accurate at higher frequencies. For example, the at voltage measurement at any port of the uh, at any port of a network will change depending on where the measurement is done, because the behavior between 2 points changes due to the higher frequencies. So it will the measurements of voltage and current will be dependent on the person taking the measurements. Short circuit and open circuits are not easily uh, generated phenomenon in microwave frequencies, because as we have studied in transmission lines, to obtain a short circuit or an open circuit, and not just the load impedance, an appropriate length of transmission line also has to be uh, accurately measured and be a part of the system. Also, this length is dependent on the frequency. So, getting the short circuit and open circuit conditions is difficult. Short circuit and open circuit conditions is what were used to calculate the Z parameters. So, hence Z parameters, Y parameters. So, hence Z parameters and Y parameters cannot be easily applied to microwave frequencies. So the way the microwave network is treated as, at any port, there are definitely two waves. One is the incident wave and one is the reflected wave. As the incident wave can be thought of as the wave which is incoming, going inside the port, and the reflected wave is a wave which is going out of the port. So an incident wave at any port can lead to reflection at that port itself due to that incident wave, and uh, a reflected wave at all the other ports. The parameter SII, or this reflection, is captured by the parameter called SII. SII indicates the amount of reflection at port I due to incident wave at port I. The parameter Sij indicates the amount of reflection or the output wave at port I due to incident wave at port J. Such values are calculated. All these values are calculated for the port for the network, and a scatter matrix is generated. So if it is a 3 port network, then it will be a 3 cross 3 matrix. If it is an n port network, in general, if it is an n port network, it will be an n cross n matrix, where the diagonal elements S11, S22, S33 are will give the reflection at each one of the points, while all the other elements like Sij in general give in the reflected voltage at ith port when the incident voltage given the incident voltage at the j port. Sij is a complex number. The magnitude of this complex number tells us the amount of reflection, the ratio of the reflection, while the phase gives us the uh, phase difference between the incident and the reflected voltage. When a measurement is done, a reference plane is given. A reference plane is part of the is given as uh, part of the measurement, because with the change in reference plane, the change in the measurement of incident and reflected voltage changes, which would change the values. Hence, it is necessary to give a reference plane as a input to the measurement. Let us consider an example of a two-port network. Here, the incident waves is given by A1 and A2, and the reflected wave is given by B1 and B2. So the reflected wave B1 is going to be the reflection due to the A1 and reflection due to A2. Similarly, at B2 it is going to be due to A1 and A2. S11 is called as the reflection coefficient of port 1. It is given by B1 by A1 when no incident wave is applied to port 2. S22 is given as reflection coefficient at port 2 when no incident wave is present at port A1. S12 is the attenuation for the wave traveling from port 2 to port 1 when there is no incident wave at A1. S21 is the attenuation for the port traveling from port 1 to port 2 when there is no wave at A2, incident wave at A2. So this is a process for a two port network, and similarly for an n port network, all the S parameters are calculated, and this defines the scatter matrix of the network. What are the properties of the microwave port? So the first property of the microwave port is that it is reciprocal. So energy that flows from I to J is equal to the energy that flows from J to I. Or in other words, the attenuation that is faced, that a signal propagating signal experiences while flowing from port I to J is equal to the attenuation that the signal will face if it moved in the opposite direction, which is from port J to I. This implies that in the scatter matrix, Sij is equal to Sji. The second property of the network is that it is a lossless network. So no amount of power is lost in this network. Whatever power is delivered by as an input to all the inputs is reflected out of the inputs of the network. This second property implies that S into S star transpose is equal to an identity matrix. Thank you. Now we will look at example of a simple E-plane T. E-plane T is a three-port network, microwave network. It is one of the simplest three-port networks. The properties of the E-plane T are uh, whatever input that comes out of port 3, that comes into port 3, are split equally but out of phase from port 1 and port 2. The inputs from port 1 and port 2 subtract